Okay, in trying to calculate the magnetic field here due to some current segment, we need the R vector, and the magnetic field is K prime I delta L cross, I'm going to use R hat because that's kind of a common symbol for a unit vector in the direction of R. So I don't have to write R over magnitude of R. But that's what this is, unit vector R. This is the way I've given it to you. I double checked to make sure I specified that that was a unit vector when I defined this. Because, you know, and I had. And I kind of thought maybe I hadn't, but anyhow I did. Over R squared, where R is the magnitude of, R without a vector is the magnitude of R. We know this. So we now know the magnetic field out here. And if we've got this thing, we just sum it up over all increments and then shrink the increments to 0, which means we do an integral, assuming we have a parameterization and get something we can actually integrate. You'd have to have kind of a nice path, but that's what you get. Now, if I've got that now, if I know the field at this point, so now I know the field is in some direction with some magnitude, right? And I've got a current, then the field relates to the current segment, and trying to write I delta L, and I wrote delta delta L. So I got an I delta L here, right? And we had a problem with that. People did pretty well with this, didn't quite remember the law exactly, but everybody knew you needed this distance. Not everybody remember there's a cross product involved. You got to get that down. You just got to nail that. As I advised you, you need to sit down with your book, go through all the chapter reviews. It wouldn't take you an hour. Write down the things that you recognize, and put little stars around the ones that are fundamental. You might not be right, but at least you'd be thinking about what's fundamental and what isn't. Okay? Then look at the principles that I laid out. You know, you ought to review that at least a couple times a week and say, okay, now I understand that thing, I just saw it. We just did that in lab. Okay? Okay. So anyhow, the thing that's easier to remember, I think, is QV cross B, which is the force on a charge Q moving at velocity V in a magnetic field B. Okay? And as we said the other day, this is equivalent to an I delta L cross B. If this is so, so's this. Now, of course, this is an approximation. If you have a delta L, it's really I dl cross B, where dl is an infinitesimal increment, right? So this is exact. This is an approximation. But it's totally consistent as you approach delta L equals 0 as a limit. Okay? Okay, well, if you want a force on the whole wire here, you've got to do this. You've got to subdivide it. And then you want to express that as a sum, so you don't just write down an integral that you think might be right. Okay? If you do the sum, and then you check the integral and check that the integral has the right dimensions and all that stuff. Yeah, that's tough. I mean, if you can do that, if you do stuff at that level with the stuff that we're doing, you're good. You'll make an A. Okay? If you can do all the stuff we're talking about at the level of conceptualizing and implementing this. With simple, I mean, it'd be like circles or straight lines. And of course, this is quite relevant to your desire to beat the Chinese with a better railgun. Okay?